Once again, good morning, Gen Math students. Today, we'll first discuss lesson 3.8, and it's about the laws of logarithm. Our keyword today is law for our memory verse, and it's found in Psalm 119, verse 142. It says, "Your righteousness is righteous forever, and your law is true." For today's MVCA boosters, it's about the 10 Commandments. The Bible also has laws written in it. Read about the 10 Commandments in Exodus 20, verses 3 to 17. And here's your question. How can we keep the law? At the end of today's class, you'll be able to simplify logarithmic expressions by applying basic properties of logarithm and illustrate the laws of logarithm. Here's our venture activity that we will answer before the class ends. The leaf and the branch. In the leaf, this is the expression written. What is its corresponding expression based on the branch? Now, to understand better the laws of logarithms, we need to recall the three laws of exponents. The first law is the product rule. When we multiply the same bases, we simply add their exponents. Example, x squared times x to the fifth. Same base, we just add the exponents. So the answer is x to the 7th. Next, when we divide the same base, we simply subtract their exponents. Example, x to the 5th over x squared. Same base, we simply subtract the exponents. The answer is x to the 3rd power. Next, when an exponent is multiplied to another exponent, we simply multiply their exponents. Example, x cubed raised to the 5th power. We multiply both the exponents. So the answer is x to the power of 15. Now, we have basic properties of logarithm, and you need to familiarize yourself with this one. Again, b should be greater than 0. The base should be greater than 0 and should never be equal to 1. First property, log b of 1, the answer is 0. So example, we have log 7 of 1. The answer to that is 0. Because when you convert this to exponential functions, this will be 7 to the 0 power equals 1. So the exponent is 0. Like, what will you raise to 7 to make it 1? The answer is 0. The next, log b of b to the power of x is equal to x. Example, log 7 of 7 to the power of 2x. When the base and the anti-logarithm are the same, we cancel the 2 and the answer will be the exponent. The next one, log of 10. Remember here, this is 10 here, that's 10 there, right? The exponent is 1, so we cancel the base and the anti-logarithm. The answer is 1. Next, when we have log x is equal to log y, you can, on the same base, you cancel the logarithmic sign, then x is equal to y. Example, log 2 of x is equal to log 2 of 4. Same base, so cancel the logarithmic sign. The answer will be the anti-logarithms. X equals 4. Next, If x is greater than 0, then b log b of x is equal to x. Example, 7 log 7 of x is equal to 5. This is the base. The exponent is a logarithmic of the same base. So we cancel them. Then the answer is x. Now, how about for natural logarithms? The same with the first one. ln of 1, 0. ln of ex, ln and e, you cancel them. The answer is x. ln of e, actually just cancel. When you have ln, the inverse is e. So we cancel them. You have 1. Next, ln of x equals ln of y. Then cancel the ln's. X is equal to y. The next one. So let's have some examples, some drills. Prepare your chat box. Ready for a review? Number 1. What's the answer for log 7 of 1? In your chat box. What's the answer? Log 7 of 1. Very good. What will you raise to 7 to make it 1? 0. Next, ln e to the power of 9. What's the answer? ln e to the power of 9. I told you that ln and e are inverses. So we cancel them. That's 9. Number 3, e to the power of ln 8. E to the power of ln 8. E and ln are inverses. So the answer will be 8. Very good. Next, ln of e minus ln of 1. ln of e minus ln of 1. That's the answer. The value of ln of e, remember we cancel it. The answer is 1. Minus ln of 1 is 0. So 1 minus 0 is 1. Next, log 10. Log 10. Remember, there's a 10 here. It's a common logarithm. Very good. Cancel them both. The answer is 1. Number 6, ln e cubed. ln e cubed. Very good. You cancel ln and e, we'll get 3. Next, ln of e plus ln of 1. ln of e plus ln of 1. Very good. This is 1. This one is 0. So the answer is 1. The last, 5 to the power of log 5 of 2. 5 to the power of log 5 of 2. Very good. You cancel 5 and log 5. The answer is 2. I think you're ready for the first part of the test. Now let's go to the laws of logarithm. There are 3 laws of logarithm. We have the logarithm of a product, the logarithm of a quotient, and the logarithm of a power. Now, remember that b should be a positive number, not equal to 1. And x and y are positive numbers, and n is a real number. Now, if you have xy, if you will expand, let's do expansion first. If we will expand it, the multiplication becomes addition. So example, you just distribute log b of x plus log b of y. If you have division, once you will expand it, it will turn into a subtraction. And if you have an exponent n, to expand it, n will go before the logarithmic sign. Again, multiplication, expand it, addition. Division, expand it, subtraction. Then exponent, expand it before the logarithmic sign. Now, here are some tips. If you will expand terms with a combination of 2 or more laws, it is just, again, it's only my observation on how to do the technique. If you'll have 2 to 3 laws, you can start with, I say, actually QPE, quotient, power, a product, exponent. Quotient, product, exponent. Now, if the whole anti-logarithm is raised to a power, then you start with the power, then after the quotient and the product. Let's have some examples. Example. You just look at the anti-logarithm. Here, the anti-logarithm is 7x. It means it's in multiplication. So multiplication, expand it, it will become addition. Copy log 3 of 7 plus, copy the logarithm again, log 3 of x. That's the answer. How will you know it's the final answer? When the anti-logarithm is just a single number or a single variable. Another, look at the anti-logarithm. It's division. So we will have it in subtraction. Log 4 of 7 minus log 4 of x. 7 minus x. There. Any questions? Again, please feel free to raise your hand if you have questions. The next one, you check on your anti-logarithm. There is an exponent. So the exponent goes first. We have 5 log x. The next one, here, your anti-logarithms are u v squared w cubed. Remember our sequence QPE. There's no quotient, but there's product. So we start with the product first. Again, once you expand multiplication, it becomes addition. So we have log 2 of u plus log 2 of v squared plus log 2 of w cubed. You check your anti-logarithms again. Again, it's only in simplified expanded form if there's only one variable, there's only one letter, one number, and there are no exponents. This is okay, but these two still have some exponents with them. So we expand it more. You have log 2 of u, that's for the first one. The second one is 2 log 2 of v. The exponent is placed first. And the last, the exponent is placed first again. You have, 3 log 2 of w. You check your anti-logarithms. That's u, v, and w. Already in simplified expanded form. That's the answer. Let's have more examples. Ready? Okay. The first one. The whole anti-logarithm is raised to an exponent. So the exponent will go first. You have 3 log 3. Then this one inside is in subtraction. 3 minus log 3 of x. Then we distribute 3 before the logarithmic sign. So we have 3 log 3 of 3 minus 3 log 3 of x. However, you can still simplify this one, right? Because log 3 of 3 is equal to 1. So you have 3 minus 3 log 3 of x. That is now the answer. Any questions? Let's go to the next one. Now, if you have radical signs like cube root or square root, remember that this one, a cube root is the same as a fraction exponent, 1/3. If you have a square root, it's the same as x to the power of 1/2. So this can be written as log 3 times ABC to the power of 1/3. The whole anti-logarithm is raised to the power of 1/3. So this one will go first. We have 1/3 log 3 of ABC. Let's simplify ABC. We have 1/3 log A plus log B plus log C. Sorry. Oops, I erased it all. Sorry. I clicked something with my pen. There. So we need to distribute 1/3 to all. We have 1/3 log 3 of A plus 1/3 log 3 of B plus 1/3 log 3 of C. This is now the answer. Any questions? Now, how about we go to number 4? Here, there is a division. So quotient first before products, okay? So we have log 4 of 5xy minus log 4 of 2x plus y. If you'll check, 2x plus, wait first, did I make something wrong? That's okay. Log of 2x plus y. So let's have this expanded. It becomes log 4 of 5, that's addition now, plus log 4 of x plus log 4 of y. How about the other? Let's distribute it. Minus log 4 of 2x. We can expand this. Let's just have this one first. Wait first, minus. Let me first start with the inside, okay? Log 4 of 2 plus log 4 of x plus log 4 of y. But since it's a division and there's a subtraction sign, you need to distribute the subtraction sign to all. So it now becomes log 4 of 5 plus log 4 of x plus log 4 of y. The next one, minus log 4 of 2, the first, the second, minus log 4 of x, then the last, minus log 4 of y. Actually, you can cancel this one. Log 4 of x minus log 4 of x. Log 4 of y minus log 4 of y. So our answer can be log 4 of 5 minus log 4 of 2. This one. The next numbers You can do it on your own. It's just an easy one. Any questions before I'll go to condensing, the opposite? No questions? Let's go to the condensing. Now, in expansion, there's one single logarithmic expression, you expand it. In condensing, there are many terms and we'll merge them into one. So I told you a while ago, that is the opposite. Now here's a tip in condensing with more terms with two or more laws. If in expanding, you have the QPE, quotient, product, and exponent, in condensing, we can do the other way around. The EPQ, that is exponent, the power. Next is the product and the quotient. So let's start. Again, EPQ, like here. This one goes before the logarithmic sign. We know it's an exponent. Let's start first with E, exponent. Ready? Log 3 of x to the power of 12 plus exponent log 3 of z to the power of 12. Next, minus log 3 of y to the power of 3. We are done with the exponent. Next, you go to product next. It means the addition. Make it into one. So we have log 3 of x to the power of 12, z to the power of 12. The last is the quotient, the minus. Divide it all by y cubed. This is now our answer. Any questions? No questions? Let's go to the next one. You check. No exponent, no exponent, no exponent. And then the last one. This is good as 5 to the power of 1/2. Because the last one looks like this, 1/2 log of 5. So the last one is log of 5 to the power of 1/2. Next, we're done with the exponent. Quotient, you look for minus signs. There are no minus signs, right? So no need. The last, product, plus signs. So we have log 6 times 11 times 3 times 5 to the power of 1/2. We just multiply these wholes. We have log 198. Write this in radical sign, square root of 5. Any questions? No questions? I'll go to the next one, okay? Okay, for the next one, we start with the exponent first. Here, that is log 6. X to the 1/2 is the same as square root of x. Next, this one, log 6 square root of y. The next, log 6 square root of z. The first is log 6 of w. There is no quotient, so that's x. Let's go to the product. We have log 6, just multiply them. W, and the one inside is square root of x, square root of y, square root of z. So you make one radicand for all of them. Again, you can only combine this if they have the same index. Example, they're all square roots. So it's okay to write them all in one. But if one is a square root and the other is a cube root, you could not write them as one. This is the answer. Any questions? I'll go to the last one. Here, you apply now what you learned. Log 3 of 3 is 1 plus, or we can do it this way. Let's do the condensing, okay? Log 3 of 3 times 4. The answer is log 3 of 12. Actually, you can also write it as 1 plus log 3 of 4. The last one here. Again, you will be tempted to write this as log xy. But remember, they don't have the same basis. So if they don't have the same basis, then you could not combine them. You could not condense them. So this will be our final answer. Questions? Let's go to the next one. Ready? The last one is this. If log 2 is equal to A, and log 3 is equal to B, and log 5 is equal to C, express each in terms of A, B, and C only. It means that if you have 60, you need to write it as a product of 2, 3, and 5. So example, 60. I do prime factorization. 60 can be 6 times 10. Then 6 can be 3 times 2. While 10 is 5 times 2. Therefore, I can write 60 as 2 squared, because there are 2 2's, 3 times 5. So log 60 can be written as log of 2 squared, 3 times 5. Let us expand it first. There's no quotient. Let's go to product, QPE, because we do expansion. Log 2 squared plus log 3 plus log of 5. Then exponents, 2 log of 2 plus log 3 plus log of 5. And we have an answer here. Log 2 is A. So this will be 2. This is A. 2A. Log 3 is B plus B. And log 5 is C plus C. So log 60 can be written as 2A plus B plus C. Let's try the last one. 90. 90 can be 9 times 10. 9 is 3 times 3. 10 is 2 times 5. So log 90 can be written as log 2 times 3 squared times 5. You find my technique. My answer without expanding is this. A, 2B plus C. That one. Any questions? No questions?